Hello, can you hear me now? Hello? Yes? Okay, very good. Good morning. First of all, let me paste the... Okay. Yeah, this is a link to take your attendance. Okay, please go to the link and then...
Okay, good morning.
ID.
We start this chapter, bit about this Friday test. Okay, so this Friday, the mid-semester test, test. So the time is from to 3:40. So before the test, I will create an online link, just like your lectures. Okay, the WebEx link. So you need to log in 15 minutes before test started. Okay, just to give you some instructions how to fill in the test and also how to submit. Okay, so a very important thing is please ensure that you can log in to Syswamil. So if you cannot log into Syswamil, I don't know how you can take the test. This one important. Please ensure that you can log in to Syswamil. So that's why last few weeks ago, I create the link for you to sign your attendance. Yeah, this one very important. Don't forget your password on that day. Okay, so I will send the question link to your Syswamil, okay, on that day. So after you log into your Syswamil, basically you can click the link. Can go back to the previous question to check. No, it's something like your attendance is one page. Okay? It's not like NetAcad. It's one page. Everything in one page. Yeah, everything in one page. Okay? It's not question by question. It's one page, just like what you did for your attendance. Okay, so the topic covers. Okay, the topic covers will be chapter 1 to 3. The generic abstract data type, recursions and exception handling. Okay, topic 1 to 3 So duration is 40 minutes, number of questions is 20. Type of questions, so select one, select more than one, and fill in the blank. So for filling the blank, it's only one word. One word. So if the thing is one word, it's case sensitive. Okay? Example, let's say a character class. So character class, the C must be capital. So if you put this one, wrong. Yeah? Later I will answer some of the questions. Okay. So, but if the question is number, okay, example, let's say the answer is 6. If you put 6, wrong. Okay, put number. Please, okay? Because I use the matching to match your answer. Okay, it's not marked manually, it's marked automatically. So be careful. Okay, case sensitive. This one correct, this one wrong. This if the answer is number, you put number, you don't put the number in word. Okay, 6 wrong. Okay, let me answer some of the questions. Before that, so once you complete the test, after you submit, please stay online. Means please stay like now in the WebEx, because I need to double confirm whether you submit or not. Okay, I need to double confirm. Okay, next. Is one page of all questions or one page for one question? One page, all questions. Yeah, one page, 20 questions. And then, got any specific Java versions? I don't think the question will ask about the Java versioning. Okay, it's the one we studied, the latest. Okay, no programming. Everything is, sorry, the programming is not writing program. Maybe I will give you a program. You let me know the output, something like that. Yeah, it's not ask you to write program. MCQ, remember MCQ? Select one, select more than one, and fill in the blank. 3 types of question only. Okay, one more is the question is problem solving. Definitely problem solving questions. Okay. Problem solving, everything is problem solving. And then will it minus mark if wrong? No. Okay, no minus mark. 20 questions, if you get correct, you get 1 mark. If you wrong, 0. Do not minus 1. Don't worry. Yeah, so make sure you fill in everything. Yeah, I won't minus mark. No worry. Means if you take the wrong answer, just 0. Okay, I won't minus mark. Will ask any Java document questions.
That's a new.
I think so. The question is very simple one. You look at the question also, you can answer. But it's most is follow Java, means problem solving question. Okay, problem solving type of question. Okay, no worry, it's quite simple. Maybe got 5 questions is tough.
Okay? So
the rest is very simple. Especially this type of question. This type of question is difficult. Okay, select more than one. Because you don't know how you want to select 1, 2, or 3.
An algorithm, not really data structure. But
yeah. So I think I informed you already. So how to know whether it's select 1 or select more than 1?
I would like to remind you.
If the question is radio button, just like the gender, male or female, you can only select one. The one is select 1. So if the question is something like a checkbox,
conducted online,
that means you can check, tick. Those are the one more than 1.
The test will be will take about
clear?
Okay, the test will take
just like when you sign in your attendance, the one is yes or no, only one choice.
There are 20 questions.
Correct. Select more than 1, you need to select all the correct one to get 1 mark. That's why this is the tough one.
Or multiple.
Okay.
In the blank.
So the select more than 1 is the tough questions.
Study, of course.
Or MCQ.
You do
tomorrow, not tomorrow. Friday.
To refer to some
remember Friday. Not tomorrow. Type of question. These 3. And select 1, select more than 1, and fill in the blank. Select 1 and fill in the blank is quite simple. The only question is tough is the select more than 1.
Refer to all those notes or whatever you have
at
the time you take the test.
Clear?
Enough time to finish.
Okay, done.
So
we will continue with chapter 8, sorting. Sorting. So later we will study different type of sort. algorithms. Okay? And then this week, we will continue with tutorial 8 and lab 7. Okay, then we start first. Okay, what is sorting? So basically, sorting is a process to sort or put the unsorted list into order. Okay, example, let's say I give you numbers. Okay? We generate 10 random numbers. Usually, these numbers are not in orders. Sorry. So what we need to do is we need to sort this number. Basically, there are two sorting sequence. One is ascending and one is descending. So that's why in my sample code, you can see I have a constant variable ascending and descending. So ascending is basically from small to largest. And then descending is from the large numbers to the small numbers. These are the two type of sorting sequence. Ascending and descending, two only. Okay, they will not be random sorting. So only two, ascending or descending. So basically, if you want to test all the sorting algorithm, so we need to create a class. Okay, so that we can create our sort method, okay, sorting method. So later we will go to the sorting class. So by creating the sorting class, this class will allow you to test different implementations of sorting algorithm. So that's why in the sample code, I create a class sorting test, sorting test class. So this sorting test, you can sort different types of variables, but not class. Okay, this one I didn't put in the class. Later we'll explain this. Okay, so what we need to put in the sorting class. Okay, so let us go to the sample code. So basically in my sorting class, so as you can see, this sorting class will accept an array. So the array can be any primitive type and string. Yeah. So this class I only support 4 types. So that's why you can see there's an integer type, doubles, characters, and finally string. Okay. So only support 4 types. So basically you can add on if you want to support class or object. Okay, means you can add on here. So for this sample code, this sort test only support integer, doubles, characters, and string. Okay. So this sort test basically will create an array given the size. So in this example, the size I support is 20. So you can modify that. Let's say you want to have sort 1,000 numbers. You just change the size to 1,000 and depends. Or you can put as an argument. And then for characters, same thing. Means I only support A to Z. Okay? That's why it's only 26 characters. And then the random number. Okay? If let's say I want to random the numbers. Okay? So basically it's 0 to 100. 0 to 99 only. 0 to 99. Okay? Because next integer max 0 to 99. Okay, not 100. 0 to 99. This one you can modify. Depends. Depends on the questions. But the sample given is only 0 to 99. Character I fix 0 means A to Z. Okay. So when we create the sort test class, basically I will create the random number. Okay? So if the type is integer, so I will create 20 random number. So if the type is doubles, again the same thing, I will create 20 doubles value. And then if the type is character, so I will create 20 characters, capital A to Z. Okay. And then if the type is string, same things so I will create 20's string. Okay. So this is the constructor for the sorting test. Okay, the next method is sorted. So this method is basically to check whether the array is sorted. Very simple. Okay, so whenever, let's say your order type is ascending, you find that there's a value, the previous value is more than the next value, straight away you return false. Means the array is not sorted. Okay, same thing applies to if the order is descending. So if you find a value is smaller than the next value, then straight away return false. So this is sorted method is just to check whether the array is sorted. That's all. So if let's say I loop all the values, after looping all the values, the array is sorted, so I just return 2. Otherwise, if any value is not follow the rules, I just straight away return false. Okay, to stop the follow. So the is sorted method is basically just to check whether the array is sorted or not. That's all. Okay. The next method is important. So this method is basically to swap two value. Okay. Let's say you want to assign A equal to B, B equal to A. Okay. So you must use a temporary value. Okay. Why? Okay. Let me give you one example. Swapping. This one I think last time we learned before. So let's say you have an integer A, B. So A equal to 3, B equal to 5. So you cannot A equal to B, B equal to A. Okay, so if you do like this, A will get 5, B also get 5. Okay, why? Because the first statement A equal to B means A equal to 5. So when the value of A change, B equal to A, so B will be equal to value 5 also. So cannot. So that's why in the swap, okay, temporary variables to hold the value of A. Okay. So example, let's say I put the temp here. So you need the temp to hold the value of A. Okay, then only A equal to B and B equal to temp. Then only you can swap the value. So this swap method is basically to swap the value of index 1 and index 2. So I just pass in the index. Okay, just like A and B lah. A and B. This one is simple. And then the next one is to show all the values in the array. Here I put a rules for the output. So every 10 numbers I print a line. This is just the rules. Means after you print 10 numbers, you print the next line. So that's why let's say you increase the size to 1000. So you can have 100 lines of numbers. So these are all the basic method. Show value, swap, is sorted, and the last one, sort test. The constructor. Later we'll discuss all this. This is the base. So once we have the base, the next one is we need to study a few types of sorting algorithm. So this sorting include selection sort, bubble sort, insertion sort, merge sort, and quick sort. So we will choose all these 5 types of sorting. So in your fundamentals of programming, I think last time we only studied one method, the bubble sort. Okay, so today we will study 1, 2, 3, 4, 5. 5 types of sorting. Okay, now we go to the first one. Okay, the first one is called selection sort. Okay, what is selection sort? We look at the definitions. The smallest elements from the list, and then replace it with the current locations. the complexity of selection sort is O(n) squared. Okay, what is the meaning O(n) squared? O(n) squared means, let's say your n, you have 10 numbers. 10 numbers. So the worst condition is you need 10 times 10 step. Okay, means 10 numbers, you need 100 steps. The worst condition. So that's why you have this complexity. You will study this one, complexity, in your algorithm analysis and design. Okay, so I won't talk more about this complexity. Later, when you study algorithm analysis design, you study a lot about this. Okay, but for this selection sort, the complexity is O(n) squared. Meaning means if you have 10 elements, you need 100 steps to complete. Take times. Okay, how to do this selection sort? Okay, let me give you one example. Yeah, so take out this one. Okay, let's say we have only two numbers. Two numbers. Okay, we look at the algorithms. Okay, only two numbers. Okay, let's say I put the big one here, the small one here. Okay, so what the algorithm do is select the smallest elements from the list, replace it with the current locations. Means if you only have two numbers, you start from the first number, and then from the list, look for the small number. So in this condition,
another thing, before we go to the sorting algorithms, is
so the smallest number in the list is 3. So you just swap 3 and 4.
Okay, in study of algorithms.
Okay, meaning if you have two numbers, you just need 1 times to finish it. Okay? That's why there's an algo for current going from 0 to size minus 2. So if your size is 2, so 2 minus 2 means 0 to 0. Sorry, 0 to 0 means one step only. 1 time only. Okay, two numbers you can't see a lot of different. Okay, let me put more numbers. Okay, this example.
Let's say we have n algorithms here. N elements.
Okay, 4, 3, 5, 6.
So for some algorithms, the additional.
Okay, so what the list do is 8, 3, 5, 6. Okay, starting from the first location. First location. First step is first location.
What I mean is
find the smallest
elements we have. N element we have. Okay, we only need one more. Okay.
Modify this one.
Additional operations when we have one.
Okay, so from first location 8. So I find 8 is not the smallest. So check with 3. Okay, now 3 is the smallest. So 3 compared with 6. 3 still the smallest. Then 3 compared to 7. 3 still the smallest. So you swap 3 with the first location. To become 3, 8, 6.
Okay, increase the time we need by n.
Okay. Once you settle the first locations, now you go to the second locations.
Algorithms need even more. And
so starting from second locations,
that means
you find the smallest.
For example, okay, for more concrete.
Okay. So after you find the smallest, you can see, okay, 6 is the smallest. So 6 swap with the second location. So that's why you have 3, 6, 8, 7.
Exponentially. If that's the case, then this is this.
Okay. After that, from the third location,
for example, for some algorithms,
find the smallest.
you may need
so 8 and 7. Okay. After you compare, okay, 7 actually is the smallest. So
complete the algorithm. If the nested for means that you in a for loop,
so
you need one more for loop.
okay. Finally, the list is sorted.
That's the case. Probably the algorithms.
So the concept is very simple. From the current locations,
You have only one.
you go to find the smallest.
Probably the
After that, just make a swap.
just n or n.
Yeah, clear? Okay, give you one more example in the lectures.
Okay.
This is what we did. Yeah.
N log n.
So from the array, you can see you have a few numbers. Okay, 1, 2, 6, 43, 26, 1, and so on.
N.
So the first step is, from the current location 1, 2, 6,
So
you go to find the smallest.
complexity. 1, 2, 6, 1, 2, 6. 1, 2, 6, 1, 2, 6. 1, 2, 6, 1, 2, 6. 1, 2, 6, 1, 2, 6. 1, 2, 6, 1, 2, 6. 1, 2, 6, 1, 2, 6. 1, 2, 6, 1, 2, 6. 1, 2, 6, 1, 2, 6. 1, 2, 6, 1, 2, 6. 1, 2, 6, 1, 2, 6. 1, 2, 6, 1, 2, 6. 1, 2, 6, 1, 2, 6. 1, 2, 6, 1, 2, 6. 1, 2, 6, 1, 2, 6. 1, 2, 6, 1, 2, 6. 1, 2, 6, 1, 2, 6. 1, 2, 6, 1, 2, 6. 1, 2, 6, 1, 2, 6. 1, 2, 6, 1,
So the smaller is 1. So once you find the smallest, you see, you swap 1 with 126.
This is for the space we need. I mean the memory space.
Okay? After that, go to the second locations.
No matter how
So
many
start from second location, you find the smallest.
elements you have.
Yeah, the smallest is 26. So you swap 26 to the second location.
For the computation, it's just one.
Later on, the third locations.
Okay.
Third locations 43, no changes because 43 is the smallest.
Or one. But some
Okay. Finally,
exponentially.
the fourth locations. Okay. So fourth locations, you need to swap these two items. So you get 113 and 1.
Sorting algorithm we have is selection sort. Okay.
Yeah.
Selection sort. It always
Okay. What is the meaning from 0 to size minus 2?
the list. And then
Okay. As you can see,
the current location.
the size. Okay. If you have two items,
Selection sort. The
two items, you just need one step. This is the step.
this complexity here is
If 5 items, you just need 4 steps.
for the in this nodes we only start with
Oh, I know it's 4 steps. Okay. 5 items means the size is 5. 5 minus 2 is 3. 0, 1, 2, 3.
okay, because for time complexity
Means 4 steps only.
also can study whether it
Okay. Means if you have 5 items, you need 4 steps. If you have 10 items, you need 9 steps.
that means it's not very good.
Okay. They always reduce by 1 because the last one usually just swap.
For n squared.
That's why you no need to have 10 items,
Can find
10 steps.
which is even
10 items, you just need 9 steps.
harder to sort. Okay.
Complexity On square
Selection sort.
is the maximum.
The algorithm actually is very simple.
Okay, you cannot calculate very accurate one. Like okay, 100 items, 99 steps. We don't do like this. We just put On square. Means On square means you need
until the
2 for loop.
last element in the loop.
One for loop to
Is the second last element in the loop.
control the step.
And start from
One for loop to check the item.
in the array. So for the first element in the array until
Okay,
the
lah?
last element.
We understand the concept first.
So
This one clear? How we swap.
the index in the array.
Okay. Once we understand the concept, okay, let us look at the sample code.
With the smallest.
We go
Okay.
selection sort.
Keep on doing this. So from the starting, okay, you
Yeah.
can find the.
Look at this one, selection sort.
You can find
Okay,
the
so the selection sort is I start from I equal to 0 lah.
So this is an
Okay. After that, the array length minus 1. You see, always array length minus 1. Then some of you ask me, hey, sir,
there are 5 elements in the
just now you see size minus 2.
5 elements.
Why now is size minus 1?
6 second.
Because I use less than.
6 4 is 1.
Okay. If you want size minus 2, you less than equal.
So it's
Yeah, never mind one.
element.
Okay, same. It's the same.
It compares to the
Yeah. So
element.
I less than value dot length minus 1 is actually from 0 to size minus 2 lah. The same.
It's
Okay.
smaller than
So what I did is the current location, the first location is 0 lah because you want to get
ascendingly.
array always start from 0 ma. So you want to swap the 0
The front largest.
with the minimum.
So
So what is the method get minimum index? Get minimum index is you want to find which index consists of the minimum value.
then okay, it keep on going.
Yeah. Let us look at this method. So when we go to this method,
Is it less than
at first I equal to
this one?
0. So my temporary value is 0.
Okay, but it compares.
Okay. Then the next one is I want to start from
Okay,
the next value lah. What is the next value? 0 plus 1.
so
So from the 0 plus 1, I want to find the smallest numbers.
for the first iteration, the
Okay.
smallest element,
So that's why here I have two
the first position.
if conditions.
String,
So if the order type is ascending, so if I can find any values, the current values
the only difference
is more than the next value.
has been swapped.
So I record down the index.
The
Means there is the smallest numbers
this is the first.
in the next value.
So after the first iteration, we don't know.
Okay. After that, I change the temp to the smallest value.
But the important thing is the smallest.
So the loop will continue until the last item.
So after
Okay,
that,
then you know, okay, the smallest index
first number is already in the
is
smallest
index,
already in
and then the smaller values will be the temp.
yeah, 43. So we compare 43.
Okay. So once I get this, I just swap.
Okay. 26.
You see, swap method is, you see,
Smallest one, then you do
the index one swap with the index 2.
43. Swap.
Means you swap the two value. Okay, just like in the slide,
43 is here.
you swap 126 with 1. Okay, so it means you swap index 0 and index 3.
Third iteration. So
Okay,
you start comparing.
this is the selection sort.
Numbers. So is it
Any question?
anyone? Yes, it's less than, or you can say 126 and 1 is greater than 43.
Yeah, this one simple, very simple only.
So it's stop 43 and
yeah, from the kernel locations, you find the smallest.
Okay, you still do a swapping. Okay.
Yeah, so if let's say your value in the kernel location is the smallest, so no need to swap.
Then we do the last one.
Yeah, means after you check the follow until the end, your index still remain. So return back the index. Yeah? So when you return back the index, let's say I is 0, get me index 0, 0 and 0, swap. Also the same thing. Okay? No effect.
Okay, 4 iterations, but within these 4
Yeah.
iterations, all this here, we do
Just like the diagrams are, 43.
So actually there's
The kernel location is 2. The smallest also 2. So swap 2, 2.
because you have nested for loop.
Same.
Okay,
Nothing happened.
let's look at the code. Okay,
Okay, any more questions?
this is the selection sort.
Clear? This is selection sort.
So
Okay, now we move on. Next one.
okay, you see.
Before that, just run a simple sample.
It's from I equal to 0
Okay,
till
go to the main class. So basically in the main class,
length minus 1 means that
I use integer. I use integer. So the constructor, I send in ascending. Ascending.
doing swapping.
And then this is because this is integer, I just send one number. So if you send 1 means 1 is integer. So they will create the integer type.
Find the mean here.
So after that, so I will show the value
Do the swapping.
generate by the methods. Okay. After that, I apply the selection sort method, and finally I show the value.
How to get the mean?
Let's
That-
run the program.
right. How to get this one? So this one we call the method. We call this method. Start from.
Yeah, later I answer your question.
Okay.
So at first you generate, this is the random data integer integer.
3 and above.
Okay. So after selections, you can see 0 0 0 0.
Temporary.
The last value is 96.
It creates a temporary array temp. Okay.
So it means you can change if you want to modify the size, the thing you can change.
Okay.
Okay, clear? Okay, let me comment out this one first.
Index.
Then we go to the
This index equal to start.
Okay. One questions. There's one questions. Ask me why we need to put static in front of ascending.
The whole.
Okay. So the reason why I put static is
compare whether this value.
this method. This variable is a constant variable. Basically, I can use the class to call it. Okay. Example here I can put sort test dot
Actually, they are repeating.
ascending.
This part of code and this part of code is completely the same.
Okay.
But just this one for ascending order, this one for descending order.
Okay. Means if I call this, means it's actually
If you want to
1, the value.
this is what you execute.
Okay. Means I can call it outside using the class name with the variable.
If this one is
Can we make ascending into a boolean?
just
Can.
we return I.
Okay. If you don't want to use one, because only 2
Okay. To the
can you can change to boolean, true or false?
we have. So
No problem.
this is the selection sort. Okay.
Okay. Means if you don't want to use integer for this, because only 2,
This
yes, you can use boolean.
the selection sort.
No problem.
Okay. You see in the main program.
Okay. Any questions? Selection sort.
Have a sort test.
Done,
Right.
Okay. Next. Okay, this one. The next one is bubble sort. Okay, bubble sort you already familiar because this one I teach you in the fundamentals of program. So the complexity is still the same. On square means if you have 10 elements, you need 100 steps. Means you need 2 follow-up lah. You need 2 follow-up to do it. So for this bubble sort, basically we have a lot of steps. So in each step, basically we compare the current elements with the next elements. So if the order is ascending, we swap the value. Example, 29 compare with 10, you swap. This one compared to this one, you swap. Then 29 compared to 37, nothing happened. And then 37 compared to 13, you swap. This is one round. After finish this round, we continue the next round. Okay, again, begin with the first element, compare with the next element, and so on. So again, if you have 5 elements, you need 4 steps. If you have 3 elements, you just need 2 steps. The worst condition. But you need to follow. I think this one you already familiar. So let us go to the source code. So bubble sort is simple. You already know. Just like this. So we have 2 follow. We have 2 follow. So one is to check for ascending, and another one is check for descending. Means if let's say the value is ascending, if the current value is larger than the next value, we swap. So when we swap, we just swap the current index with the next index.
Easy to understand. Easy to understand.
Yeah.
And the disadvantage of this one is the time complexity is rather large.
So let us run the program. Bubble sort.
Not that efficient.
Bubble sort.
Time complexity. That means it spend a long time when the array we have.
So the original set, then the okay, good questions. Why we need to use this iteration?
Rather large. Okay, compared to some other algorithms.
Before that.
But one more thing.
Okay, someone come in late. Okay, what is the functions of ascending and descending? The sorting. Sorting.
But the space complexity is small.
This is the sorting. You want to sort according to ascending order or descending order? Ascending means small to large. Descending means large to small. That's all.
You do not get much additional.
Okay. So just now, one student asked me. Okay. This is the improvement of the bubble sort. Okay, so when you control the value, basically you can control the array size -1, and then iterations to improve the performance. We can do this. Means when you have more interactions, when the interaction become bigger and bigger, basically you can remove. Faster to improve the performance of bubble sort. If you don't want to put, also can one, no worry. But after you put, much more faster because the value of I will be smaller.
And at the end of the iteration, you put the element into the last.
If you don't believe, you can try. You can try a few times.
The last element.
You can get the same result.
The largest one at the end of the array. The complexity of bubble sort is O n square also.
This is bubble sort. Back to the next one. So bubble sort selection sort is a new one. Bubble sort, I think you know already. Now we go to the next one. Next one.
5 elements here. 29, second.
Next one is insertion sort.
And last one is 13.
Let us look at the
So at the first
definitions. The insertion sort insert the elements in its proper place.
Because 29 is smaller than, is greater than 10.
Means when you get a number, you check this number. Which index you want to insert this number?
Not the end of the first iteration. Okay, the first iteration continues by comparing the.
Okay, so but the complexity is still the same. You still need two. Means you still need n squared.
So
it means if you have 10 elements, you need 100 steps. You need 2 for loop as well.
Okay, and 37 and 13 remain. Okay.
Okay. So there is a statement here. Insert sort is better than selection sort and bubble sort when the list is sorted.
Compare the third and fourth.
Okay, means if you have the list. Okay, example.
Is it greater?
Let's say this one.
Since 29 is less than 37, so they stay at the same place.
Okay, so if you want to insert 5,
Fourth and fifth. Other fourth and fifth. 37 and since 37 is greater than 13.
Insertion sort is faster if compared to bubble sort and selection sort. Why? Because this original list is sorted.
So you see, the largest
So the insertion sort means you insert 5 at the proper location. Means you insert 5 here.
of the array.
Means 7, 6, 7, 8. You will move to the right. 1, 2. Okay. Here you put 5.
We only need to take care of
So only one step.
the number of the first,
Yeah. So that's why I put sorry.
second,
What happened?
only on the second.
So that's why I put a statement here.
So at the second iteration,
Insert sort is better than selection sort and bubble sort
14,
when the list is already sorted.
no change.
Because only one comparison.
Compare second and third,
Okay, means they insert at the proper place.
because this one is
Compare to selection sort and
this one is more than
bubble sort, you still need to
sorry, this
compare
and this one.
current value with the next value.
Swapping.
Insert sort, no need.
Okay,
Okay, let us look at the
the end of the second iteration.
algorithms of insert sort.
This is the
Okay, example, let's say we have a list.
second iteration. You see, all the numbers
Yeah, 5, 2, 4, 6, 1, 3.
are sorted.
Okay, so for insert sort is, the first step is,
At the second iteration, two numbers are sorted
okay,
at the back.
we look at
Iteration,
an array with 2 elements.
so this is 37 at the back.
Okay, 2 elements are.
7. Okay, so
Okay, so these 2 elements we swap because 5 is more than 2. So we swap. Okay, means you insert 2 in front of 5.
they get the name of bubble sort because of the elements, the largest
Yeah, means 2 and 5 you compare. So you insert 2 in front of 5.
go from bottom.
Okay, the next one is you compare these 3, 2, 5, 4.
Go up.
Okay, so you insert 4 in between 2 and 5.
So this is the algorithm.
Okay, the next one is 6. 6, you see, now 2, 4, 5 is sorted. So no swapping required.
When it's called, so it starts from
Yeah, because the list is already swapped. Sorted. Okay, sorted.
until
Okay, the next one, 1.
less than the
Okay, because 1 is the minimal numbers. So you just move 1 in front of
array.
2.
It goes through all the elements in the array, and then
Okay, and then finally 3. 3, this one is like normal because 3 is in the middle.
minus 1.
So you just move 3 to here.
That means it go for the second for loop, the nested for loop. It goes from the first element
One student asked, what if the list is not sorted? Okay, if the list is not sorted, is same the performance because still O(n) squared.
until here.
Okay, the complexity.
Is until here. Okay.
Okay, the insert sort is basically
That's the one that we have already
good.
to the last position.
Means the performance is better if you are using
Here,
linked list
two
compared to array.
but actually they do the same thing. These two
Okay, why? Why use linked list is better than array? Because if you use array, you see when I want to move 3 to the index 2, okay, 0, 1, 2,
greater than
4, 5, 6, I need to shift to the right. See, shift.
swapping. So for the
Compared to linked list, you just break the link, then you point to 3. So insert sort is better if you are using linked list. Is it only can be done with linked list? No, can use array also. Okay, but if you use array, the thing is difficult because I need to move the item, index 3 to index 4, index 4 to index 5, and index 5 to index 6. Okay, so the worst condition is if your item is the first item.
So any question for the bubble?
So all the array item you must move to the right one place. So when you want to use insert sort, it's better you use when you use linked list. Okay, compared to array.
Okay. Good.
Okay, let us look at the code. This is we are using array. We are using array. So what we did here, the same thing.
It works like this.
So we have a first for loop
Insert.
and the second for loop.
Sorry.
So if you are using ascending, so you compare the two values.
That means
Then you swap.
the smallest element first, and then
After swap, then your J, you start with the swapping locations.
is also n square.
So from swapping location to J smaller than I.
Sort is better than the section sort.
Then you swap this J and I.
This is already sorted. Okay, they don't do.
Because you need to shift. After you move the elements, let's say the element is the first element. So after you move to the first element, so the first element need to move to the second element. The second element need to move to the third element. The third element need to move to the fourth element. That's why we have a for loop here.
Okay.
So it's not efficient if you use in array.
Let's look at the example.
But if you use is linked list, it's better.
1, 2, 3.
If you want to use insertion sort.
In this order, 5, 2, 4.
Okay, any questions before we move on?
In the first iteration, it starts from the second number.
Okay, clear? Understand?
Second number. Okay. Check whether
Insert the numbers into the proper place. But after you insert, you need to shift the current element to the right.
check whether it's less than the number.
So this for loop is basically to shift.
So if it insert it at the proper place. That means you see 2 is less than 5. So it put
How to insert
5. So
without parameter?
take out the 2 first, and then
Cannot understand.
the 5 to here to the second.
The question is how to insert without parameter.
Here. The rest remains.
Can you elaborate more?
The second iteration, 2 and 5 is already sorted. Okay, since we have already insert the 2 into the front of the 5, 2 and 4 is already sorted. So it starts from the third number.
Cannot understand this question.
Just now we start from second number. Now we go to the third number.
The method I see no parameter.
4.
Is no parameter, correct?
You compare
Because okay, I know what you mean. Okay, we go back to mean.
Sorry,
Let's say we go to
so we go to the second number, 5. Since it is less than 5,
insert sort.
so it will take out first. And
Okay,
5,
because in the insert sort, this is the insert sort, right? The arrays is already generated here.
So after the second iteration, the first 3 number is already sorted.
Yeah.
The first 3 number is already sorted, and then it check the fourth number in the third.
Okay,
iteration.
wait, the next one. Okay, I'll go back to this. Okay, that's why you no need parameter because this object already created the numbers in randoms.
No, less than 5. No, that means it's
Okay? So that's why when I call, I just compare the value in the array. So no need to have parameters.
back to the simplest.
Okay, another question is the worst case complexity same with array and linked list?
Number 4 number in the front is already sorted.
The complexity is still the same, still on square.
1 take out.
Okay, the complexity is still on square. But the timings will be
All these
more
here,
when you use array if compared to linked list.
move to here, and then 1 move to
Basically, you can write a program to check the timestamp.
and then the fifth iteration.
Okay, if you sort using array or linked list, but they still need 2 for loop.
Okay, first, second.
The only
The fifth
difference is array you need extra step.
number. Okay, sixth number take out 3.
You need another for loop
No, less than 4.
inside the I for loop.
So less than 4.
So the time the thing still on square, but the time
6 to
more
here, 5 to here, 4 to
if
here,
we use array.
set 3 to the third position.
Okay? Because you see, this 2 for loop is actually inside this 4. So it's not the third level for loop. It's still the second level for loop. Means still on square.
In the list. Okay.
Okay? But the time is we need extra time just to shift the elements from left to right. That's all.
Okay. Insertion sort. Okay, when this method is called
Clear? So this is insert sort.
integer j. Okay. The integer j
Sorry.
as a
Okay, any questions before we go to next one? Next one is fast.
okay. So
Yeah, next one.
you see, in the for
Next one is called
for loop.
merge sort.
Start from I equal to 1, not 0.
Yeah.
Okay, because
The complexity of merge sort is n log n. Wow, faster. Okay, what is mean by n log? Is if you have 10 elements,
but we have in the array
why I put small letter n here?
something. What is it?
Same
Start checking the first number.
Okay, because POS use capital N, right?
I. Okay.
Same. Okay.
Checking
This one.
first number and then the I. Okay.
Why is it you cannot? Okay. N log n, capital, small n or capital also the same. So it means if you have 10 elements,
For the whole lecture, for this lecture,
you just need 10 steps.
which is doing the same.
Why? Because log 10 is actually 1 So 10 multiplied 1, 10.
That's the ascending one because they are same. Okay.
Okay.
So you see, in the for loop,
1 for loop enough.
when j is equal to 0,
Compared to just now, you need 2 for loop.
if
This one, you just need 1 for loop. Okay. What is merge sort? Merge sort means you divide the list into half.
ascending, okay, you see, with the number we have,
Okay. If you have 10 elements,
number we compare,
you divide to 5, 5.
they are the same. We do a sorting. Okay. We
After
sort.
that, sort each half.
Okay.
And then you merge the 2 halves together.
After the back, we go to doing this one. We move all the numbers to the back.
Yeah. So the algorithm here is you can see cut the arrays into half,
Okay, like this one.
cut or divide
Compare.
and then sort the left one, sort the right one, and then merge 2 together.
No. 3 is it less than 2?
Okay. Let us look at the diagrams.
So when it is yes,
Okay. Let's say you have this item
it is yes.
7 elements.
This is ascending through.
Right? 7 elements.
That means
So the first half, let's say we take 4
3 and 4.
Okay, the first half, then the second half another 3.
3 and 4. That means
Then you further divide these 2 to 2 half.
4 we put here
Okay,
temporarily.
another half.
Okay.
Means 38, 27 here, 43 and 3 here.
So,
This one,
3 and 4.
the first half is 982, the second half is 10.
From j equal to j plus 1.
Okay. Is something like binary search. Yes, almost like binary search. But now it's sorting. Okay, just sorting. Means you divide. After divide already,
Here, 4 is here.
the last step is basically
4 is
just like a tree.
and
Everything is leaf.
then 4 will here,
Okay.
5 will here. And
Single item. Just left single item.
6. 5 and 6 sort.
So
5.
from this single item, then you sort it out. See?
So
27 you compare to 38. 43 you compare to 3. 9 compare to 82. 10 no need to compare. So after you compare already, then you compare this pair.
second iteration,
2 and 2.
second part,
Then you compare this.
the second for loop is
Okay? Finally you merge.
the numbers, all the numbers in the
Okay? So the step is you divide first.
okay. So
Because when you divide, basically you can call the recursive method.
okay.
Okay? And then you can run in parallel.
Okay. The insertion sort,
You can run in parallel.
bubble sort,
Yeah? Compared to just now, the insert sort, bubble sort, and insert sort. you cannot run parallel.
Okay.
Because it's one linear structures. You need to compare one by one. This one you can run parallel.
Between all the three sorting algorithms.
Okay. So that's why
one more comment in the
sorry, the step is faster. Yeah. The step is faster. So
comment in the algorithm is
yes. After you merge, so the last step is basically you merge the two halves. So when you merge, then you compare. Just alternate, compare this one and this one, this one and this one, this one and this one, and so on. And then you get this.
okay. The this sorting algorithm. This
Concept, you know. Now we forget the concept. Okay. So to run the merge sort, basically I have a few methods here. Because later on we need to run in recursive. Recursive. So that's why when I call the merge, the arguments are the index, the merge methods. That consists of I get the middle. So this is to cut the first half. This is the second half. So when you cut the first half, basically they will call again. They will call again. Just like the diagrams are. Back to diagram. After I cut first half, recursive again. Recursive again. Until what? Until the base case is first greater or equal to large. Then you stop the base case. So this one basically these two is to cut into half until here until 1, 2, 3, 4 until here. The two merge sort is basically to cut to half until here.
Then what is 5?
After finish running the two merge sort, I need to merge. This is the part. This is the second part. You merge. The merging part. So the merging part, you can see I take 4 index. Middle plus 1 and large.
Another half.
To compare.
The 3 you break into 2, 1.
To compare the first, left first, left large, right first, right large.
Continually.
Okay.
1.
Then you merge.
2 break to 1, 1. 1 of course 1 already. And after
So after finish, you compare. If your left is less than the left large, so keep on adding the index. These are 27, 38, this one. So because 27, you see 27, compared to right first is less than 0. Means the right one greater than the so you need to swap. Swap means 3 will come to first place. After that, compare this one and this one. Because this one and this one is larger, so no need to swap. So you put in. So the merging part is like this. You need to check the left and the right. Because you have 2 groups. 2 groups. So you need to check. So after finish checking, you need to check the left hand side still got items or not. If yes, you continue. Finally the right one also the same thing. You need to check. So at the end you have all the values.
This is part of the code. So you see we do it recursively. So when
one question come in is why middle plus 1?
We pass.
Middle plus 1. What is middle?
The whole array.
Why middle plus 1? Because if you have go back to this one, means if you have 0, 1, 2, 3, 4, 5, 6. 6 So the middle is basically 3 lor. 0, 1, 2, 3. So middle is 3. So 3 here. So the next one will be 4 lor. Okay. That's why middle plus 1 ma. Yeah. This is the first half. This is the second half.
The merge sort method, you see, we do it
Yeah.
successively.
First half, second half.
First and last.
You cannot put middle again ma. Right? Means you cannot have the same value again ma.
Last is the
So that's why when you merge is you merge the first and middle.
of the
This is the first group. And then middle plus 1 large second group.
if the first is still less
Just like the diagram lah. The first group
okay, we
and the second group.
can break
First group,
okay,
second group.
do this. We find the middle.
First group, second group.
Go to the
First group, second group.
last divide
After the merge already, first group, second group.
in that
And finally you get the answer.
array. That means let's say if there's
Okay. See, when you divide like this, the process is faster.
5 here,
The process is faster. That's why you don't need
0 and 5.
ON square. You just need N log
At
N.
the beginning, first is 0. You pass the
Okay.
0
So merge sort is basically faster.
and 6 to the
Yeah, faster.
9. Okay,
Because everything you can run recursive.
we break into 2 part. Okay,
Okay. Means basically you can write a parallel program.
pass them.
Okay, a parallel program to multiple processor
Keep on doing this.
to run it.
This one we keep on doing because this one, when you go to here, run this one and this one.
Okay. Another question. What does this mean by first less than last?
This one first.
Okay, this one.
Second, but this
First less than last is
and
to stop
I break into
the recursive method, the base case.
array with 1
Okay, just like this.
only. Okay, and then after that,
After you divide until here, until here,
method. The merge
basically your first will be
the first
less than more than large.
this one.
Okay, when first more than large,
100 plus 1, that means
you need to stop already.
4 parameters.
You don't divide anymore.
Okay.
Okay.
Merge.
So if you don't divide anymore, the next step will be merge.
In the merge method,
Okay, just like you call recursive method. First you call again,
we
you call again.
2 lines.
Okay, finally only one item. So one item no need to run. No need to run. You need to go back to the previous method
We break the whole array,
to merge.
subarray, subarray, subarray until this here. Okay. And when we
Okay.
have already
The next question is, can we add sorted item to new array and copy?
to arrays,
Can we add new sorted item to new array and copy? What is the meaning?
merging.
The last one.
Okay, merging method. The merge method. So the merge method will pass this 4.
Because when I sort, basically, yes, actually I have a temporary array.
Just one number.
Okay? This temporary array is actually the final, this one.
But
The final, this one.
go to the bottom here.
Okay? So that's why in the last step, I need to copy back this temporary array to value.
At this last. So these are different numbers. When the array is not only one element.
The final value.
To the merge method.
Okay, lah?
Merge method. Okay.
So that's why I need a temporary one.
Four numbers here. First, the
Okay? For the last part.
first is the first.
Okay? After everything you merge.
And the middle is the left last, and the right first, and the right last.
Yeah, clear? This is
Middle plus 1 and last.
merge sort. Okay? Faster.
For this case, for example,
Divide by half, after that merge. Okay? So the algo is simple only.
plus 1
Just divide by half.
last. Or
Okay?
this is first, last,
Here. Okay? Divide by half, merge.
last.
After merge sort, then merge them together.
Okay.
So merge them together, you will have the left and right. Yeah, left and right. So when you compare the left first and the right first.
When this algorithm, this
Yeah.
is run,
So if sort already means you keep on adding the left
array, temp array,
until the left is more than right,
t, which is
then you add the right.
integer or character or whatever you want to
Okay.
sort. Okay.
So if still got item left,
It creates one
you check
integer called index.
whether still got item in the left
Left first.
and still got item in the right.
Value of the left first. Okay. The position of the left
Okay.
first, not the value, the index of the left first. Okay.
What is this?
Index is
when left plus,
these two numbers,
let's say left plus.
this number. So we come to a while loop.
Someone put a
While
code.
loop
What does this part do? Oh, you mean this part? This part.
is less than or equal to
This is what I mentioned. Means if left, you still got item.
right first is
Means okay.
equal to
Come back to
right
this one.
last. Okay.
Diagram.
So if
Yeah, 82 here.
we want to
Okay. Let's say there's no 82 here. We take out this 82. So when you compare, basically you get 3, 9, 10, 27.
the
Let's say no 82. Okay, we assume that no 82. So your new list is 3, 9,
one is less than this.
10, 27.
Okay.
So your left, you still got another two numbers here, 38 and 43.
Okay.
So how to insert this 38, 43 to the new array?
First, the three.
This is the one.
Okay. Into the
Means you still got item in your left hand side.
we create here. Okay. Okay. We are sorting on
Okay.
some
So
array.
if let's say 82 is here,
Value of
basically all the left one will be sorted out. Okay, and then the right, you still got one item here,
actually we are
82. So
in
this code, this one, the right one, is to check whether your right hand side group still got item or not.
smallest one in both arrays.
This is the
Two arrays
functions of these two while loop.
So we keep the tree. Okay.
Is to check any item left in the left hand side or right hand side.
And left
Usually, if sort in ascending, is the largest number left. The largest number left.
the left first become 27.
Okay?
We keep on doing
Okay,
okay. We keep on doing this
Okay, good.
until this one is false.
So I learn again.
For the case of
Let's say just try and see whether the thing is correct.
if the right one is more,
Excuse.
we put the 9 into the time. Okay.
Okay. This one is using merge sort. Merge sort. Okay, run.
Okay.
Hello?
See this one and this one is completely
Yeah.
but just if this one left one is
Okay,
smaller,
merge sort.
put the left one. If this one is not true,
Basically, if you want to test the performance, you can put more array. Okay, put more array. After that, you can actually use the
index of the time.
timestamp. Check the time.
Okay, just now time at the beginning.
Just take up first.
No,
Dis-
so now,
discuss the concept.
The index of time is 0. Now the index of time is go to 1 already.
Okay, the final one.
So we keep on doing this one.
This is merge sort.
until
Okay, the last one is basically change the n.
all the
Why I put small n here?
are sorted. Okay.
Okay, the final one is quick sort. Quick sort.
Example.
Okay, the quick sort is almost is not similar but is the same method like merge sort. Okay, means we can still divide. Okay, it's a divide and conquer, means we still need to split, but not by half. Okay, if not by half, you need to choose a value. Okay, so a value is selected. So this splitting value is selected. Just now is in the merge sort, we already fixed. Okay, everything by half. Okay, but quick sort, you can decide, you can choose a value. So this value is to let you split the group into two. Same thing also, but now it's based on value to split.
Second iteration.
Just now is based on the numbers of elements to split. Now it's based on a value to split.
This part is not executed.
Okay? So once you have this value, basically the left group,
Less than 9.
you will have all the values smaller or equal to the split value.
Okay. And then
This one important. Means the value, once we select a value, once we select a value,
third iteration.
the left part will be contains all the values smaller or equal to the splitting value. Means we will be able to get the left group sorted. But the right group not sorted yet. Only the left group will be sorted.
All these are removed.
After that, you divide again. Okay? You choose another value
In the array. We have 9 and 10
until
the left one.
you cannot divide anymore.
The left one,
So that's why the capacity is still the same.
left last.
N log n.
The left first
Means if you have 10 items, you need 10 steps.
left last is this one.
Okay? Similar to merge sort. Merge sort is
3.
fixed already. Everything by half. Everything by half.
Option 0,
This one no. This one is based on value.
3. Okay. 2 is still less than
Okay.
the position.
This is the algo, but let us look at the diagram. Easy
We will
for you to understand.
bring
Yeah, I make it bigger.
this one 9 to the 10. So we
Okay.
bring the 9
Yeah. Okay, let's say this is the list. This is the list.
go to this one. Okay.
Okay. As an example, okay, we choose the first element as the splitting value.
Also
9.
10.
9. 9 is the split value.
Okay. So this is
Okay. So you
okay.
use a loop.
So
Okay. Use a loop to check.
elements left in the
You loop until the index is more than the splitting value. So you see 9 is my splitting value.
for the left.
Then I have an index. So the index will go to the next one to check whether it's more than the splitting value. So
Only do one thing.
when you go to here, because 20 is more than 9, so we stop here already.
Remaining of the array to the temp array.
Yeah, we stop here already. The first we stop here already. The index of first.
Last for loop is here. Okay.
Okay, the next one is the index of large. Okay. This index of large you must reduce
Back to the
until
value.
your value is less than or equal to the splitting value,
Refer to the
okay, which is 9. 9. So
merge.
when I decrease the 11, the large to 60, because 60 is more than
The
9.
temp array back to the
So I keep on running.
so the value
8. Oh, okay, the first A and B and C.
algorithm work. Okay.
Okay, I repeat.
You see
Okay.
the
First, you choose a value. 9. 9 is the value.
call recursively.
Then you want to know the first locations. So how to get the first location? The value must be more than the splitting value. So I will go to the second one to check. Okay. Because 20 is more than 9, so I stop here.
Okay. One.
Yeah, I stop here.
So the
Okay. Then the algo also need to find the large. Okay. The last one is the value must be lesser or equal to the splitting value. So I will loop from the last element to the second last and so on.
okay.
Because 60 is more than 9, so I continue looping. 8 is less than 9, so I put the last here.
More complicated compared
Okay? The last one and the first one. This is the index.
insertion sort. Okay. But the advantage of it is fast.
Okay? So I will continue.
Okay. it's
Swap
fast,
the value
okay. But of course you need more
of first and large. Okay, so just now 8 is here,
array.
20 is here. So I swap these two values.
Okay.
Okay, 8 I put here, 20 I put
The
here.
other one is the one that we are going to learn today is quick sort.
Okay, after that,
Is
move first and large towards each other. Means just now first is here, now first is here. Just now large is here, now large is here. So it become like this.
the common between quick sort and
Okay. Then the step will repeat. Repeat again. Repeat.
n log n.
Okay. Increment the first until more than splitting value.
Use recursive method. We do recursive.
Okay. Or first more than large.
When you say recursive,
So I will check.
and conquer.
Okay. 10.
We
10 is
all this
more than 9. So the first will become here.
we do it separately
Okay. This one decrease.
using the same process.
Decrease until
The difference is
the value is lesser or equal. So 10 is not lesser or equal.
okay.
Looping. Decrease again.
We use the
6. 6 is less than equal. So last and first is here.
you see for the merge sort we
Okay.
do the
So
part first.
because last and first is here,
Sort here. Okay, we
first is actually greater than last. You can see the first index is more than large.
recursive.
So no more swapping.
Okay.
Okay, means the thing will stop.
Here
So when the thing stop, you sort the initial value, the splitting value, with the last index.
Find a splitting point.
So finally you get
Value.
8,
And then
6,
with the
9.
splitting value, we
Means anything below the splitting value will be sorted.
postpone the
But
result
this part not yet sorted.
at the back. Okay, so let's look at the example.
Okay, and then the process will continue. Yeah, the process will continue by choosing another splitting value.
So
Yeah, more than 9. Because the left one settled. Okay, now we continue with this group.
save first.
Can we choose save F as random? Yes, definitely.
The first position. Okay.
We can choose the save F as random. Okay, but the worst condition is if you choose the splitting value is the max value.
Okay.
That one is the worst condition. Or you choose a value that is a minimum value.
The splitting value, right? Okay. With the splitting
For
value.
example, you choose 6. Right? At the end, you only get 6 here. The rest all not sorted.
9. Okay.
How 9 and 6 swap? Okay, 9 and 6 swap is here.
So we increase.
Okay. Again, just now when I want to stop the recursive method, I use if first
Okay. In the second,
more than large. Same thing apply to this
the first
quick start. I also use
put the
first more than large.
until
Okay. So once your first is more than last, the index. Okay, you need to swap your
okay, you see. Now the
splitting value with the last value. That's why 6 and 9 swap. You see, the last item, the last index is 6. The splitting value is 9. So I swap these two.
the last remove.
This is when the base case.
The first
Yeah, when there's a base case.
value. The value is 20.
What happens if we choose the max value? You still can sort, but the performance is not good.
You see, we stop.
Yeah? That's why we can say it's a worst condition. It's the worst condition. You choose the max value or you choose the min value, it's the worst condition.
Okay.
But if you're able to choose the mid value,
We move to this direction.
not mid value lah, maybe the quarters or third quarters, that one okay.
Now it's 11.
Yeah? The worst condition is if you choose the value is the smallest or the largest one.
9.
Okay? Because later on you need to choose another value again.
You get 60.
Okay?
It's 60.
But the complexity is still the same.
Yes, it's still greater than 9.
N log N.
Moving. So when keep on moving, we get 8 here.
Okay, sorry.
9.
Okay, come. Let's go to the code. The code is a bit tough. Okay, before we go to the code, another example.
Okay. We stop. Okay.
Okay.
When we stop,
So this one is
what we do next is
the split value is 8.
we swap
8.
Okay.
So at first from this list
both numbers.
the split value is 8. So I come up. The left hand side is all the values smaller or equal to 8.
20.
The right hand side is all value
Okay. The rest
greater than 8 lah.
9,
Can see it?
6, 10, 14.
Further divide lah. Further divide. Okay, choose another value lah. 6. 6. These are all the group less than equal to 6.
7.
This one is more than 6 lah. Okay. Further divide lah. Another value lah. 4 lah. And so on lah.
Okay.
Okay.
You solve these two.
So until the last one. Okay. Sorted already. Okay. Sorted already. You can see 2, 3, 4, 5, 6, 7, 8. See? All sorted. 2, 3,
We
4, 5, 6, 7, 8.
first two.
So that's why just now a student asked, if we choose the highest value, let's say we choose 19.
Last.
So if you choose 19 here, everything is here already. See, everything in the left. So means in your right is only 19. Or I take another example. If you choose 2,
Since this one
means
when we move
your left hand side is only 2.
to 9,
Your right hand side is everything. So this everything you need to further divide.
10
The one is called worst condition.
okay. We
Like this is best condition because you choose the mid value.
sorry. We stop.
You're able to choose the mid value. But this one we don't know one. This value. Unless you go to add up, then you calculate. So, but when you add up also, you need a for loop to get the median. So, how to choose this value? There's another algo for this. The one you would, sorry, the one you study in algorithm analysis and design. Sorry. Yeah. So, but the concept still the same. They further divide. Merge sort is by numbers of elements. This one is by value. Okay. So at the end, you can see by using quick sort, at the end is very easy to merge. Compared to merge sort, you still need a method to merge everything. Quick sort, at the end you just go to the left. Continue. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Less than 9.
Sorry, 12, 13, 19.
Greater than this value. It's all greater than 9.
Okay. In this one, the bigger list is the better for, yes, correct. Quick sort, if you have a lot of numbers, it's very fast.
Start from the first value.
Provided you choose the
we start from the first value.
The split value.
And we define first and also the last.
Okay. This value very important.
Okay.
If you choose the last one, the maximum number.
And the last always move to the left. Okay.
For each row, they use different. Yes, they use different value. You see.
The position of first.
The first one they use this because you from here. Okay. Usually, what we did is we divide by half. Same thing also. Okay. Let's say at first is value 8, then 4, then 2.
Okay.
But this one they're randoms. They just want to make it very good performance.
Oh, the one that
usually we divide by half, or we double. Means if here is 8, here become 4. Here is 8, here become 16.
Come to here. You see this one.
Depends.
Come to here.
How to choose this value is also another
You see?
what to say? Problems. Okay. What is the best value for
this one?
Quick sort?
Less than this one. This one is greater than this one.
But at the end also the same.
This one is greater than
the performance is similar to merge sort. Is n log n. Okay. N log n.
Less than 20.
Okay. Let us look at the sample code. We go to sample code.
We keep on doing this. Okay. Until.
Okay. Same thing.
Okay. Stopping. Until.
So first
followed by last. Now become last followed by first.
I have a method. Okay. Just to call from the object. Okay. So quick sort. Okay. Without arguments. This one without arguments. Okay. The next one is basically the
last one with the first.
Inclusive method. Okay. It's similar to merge sort. Also base condition if your first is more than equal to large. Okay. So the base case is if the first is more than or equal to large. Okay. But the only difference here is I need a split index. Just now in merge sort, I straight away calculate large. First plus large divided by 2.
Less than 9.
Okay. Still remember? See, go back to the merge sort.
Less than.
See?
Greater than 9. Okay. On the left.
The half. Okay. First plus large divided by 2. This is merge sort. Quick sort, we find the index. Find the index. Okay. How to find the index? This is the algo.
9 may not at the middle point. You see?
Okay. See? So long.
There's only 2 elements here. 5 elements here.
Yeah. This is the algorithm to find the index of the split.
We keep on doing this to break the list. What I mean? Just now we have a list of 6. 4.
So after you find already. After you find already.
So we keep on doing the same process.
Here, you see, I straight away use the first item. I don't care. I follow this algo.
The recursive call. Okay. We keep on doing this.
I follow this.
For this one.
I use the first one as the split value.
So
I'm not using any random. So in my sample code,
Okay.
I use the
So you see just
first,
this one.
okay, the first one.
This
That means
So
after, let's say here, I will use
yeah,
8.
it's a
After that, I will use 6. Follow according to this. Okay?
element.
The first one, 8, 6, 4. I use the first item.
Okay.
Okay? 12,
The whole list into two parts.
10. Okay?
Okay. 8.
Use the first one.
You
13.
whole list into two parts.
Okay? So my sample code, I use the first one.
The one
But this one, if you don't want to use the first one, you can change. Yeah? Depends how you want to calculate.
which are all the values greater than 8.
This one, I use the first one. So after I use the first one, basically this split method, okay, this split method will help me to get the two group,
Okay, or sub-array.
one group and second group.
We use the same method.
Okay, after I get the first group and second group,
6 we use as a value.
I will further divide.
So you see,
Further divide. See?
you get 2.
Recursive again.
This one is all the value
Okay, but when you further divide,
greater than 6.
very important.
It's in the middle of these two.
The first index is first. The second argument is, you can see, split index minus 1.
You break the whole array into 2.
Just now in your merge sort is first to mid, then mid plus 1
And then for
to large.
this one since only one value.
This one must be careful. This one is
4 values.
first
Okay, 4
to the split index minus 1.
we use 4 to break into 2.
The next one is split index plus 1 to the large,
Greater than 4.
not to the last. Last.
To 2.
Okay.
Three value. You
Okay,
also
whatever.
10. The first value.
Okay. First to split index minus 1. And then the next one is split index plus 1 to last one. Okay, why? Okay, go back to the diagram. Because the split value
Array,
will not be involved in the
small array.
to divide anymore. You cannot divide the split value inside here anymore. You just divide here only. So you leave it here.
When
You don't touch it. That's why split sorry,
array
split index minus 1.
already sorted.
Okay?
See, there are
First to split index minus 1.
5, 6,
Then split index plus 1 to last.
9,
The last one.
11,
You don't take this one
14.
into here. You leave it here.
The last thing you do is just
Yeah?
put them
Get up?
according to the
Otherwise later you got big problem. That's why here the one is minus 1, one is plus 1. So after you settle everything,
method.
at the end of the day,
You call the quick sort from the first element to
this one is to get the two group.
recursively.
After you get the two group, basically,
Call the
finally, you should be able to get the complete
with these parameters.
list like this.
Okay, so you pass the 0 and the
Okay? After you split everything, at last, you should be able to get the index in proper place.
if the first is still less than last,
Okay, so this is quick sort.
that means this one. This case, first is still less than
Yeah, clear? Okay, so you can see the value I choose
the index
is the first one. Okay, I follow the
less
diagram.
than. Okay, and this one less than.
If you want to change, you can change.
Still less than until this one less. The last is less than the
Okay?
first. Okay, until here. Okay. Okay.
Okay, this is to compare the side.
Method.
Okay, each side.
We call the split method. Okay.
Okay, and then you swap if the value is
We call the
greater than the first and so on. Follow this this concept.
the first and last.
Follow this concept.
Okay. To the split
Okay.
method. Okay. You keep
Okay.
on doing this
So
one.
we run again.
Then eventually you get
Later, let me run again.
When
Merge sort.
okay, and then you quick sort
You get the answer lah. Okay.
split point. Okay, keep on doing this. Okay, for the left and the
Okay. So one student asked, what is the use of the collect side? Okay, collect side.
this is what I mentioned just now. To create the
Okay, collect side means if you sort according to ascending, the correct side is basically the left.
and then you create a temporary value.
This one, the left side.
Okay, which refers
Yeah,
to the first
means
element,
the one smaller or equal to the splitting value.
and then the index is
Okay.
first also.
The one
So, and
uh,
increase
smaller
one,
or equal to the splitting value.
and then
So if the thing is bigger than the grading value, okay, you stop. Okay, just like this.
so
Okay, you loop. So means if the thing is already greater, so you stop.
elements,
Okay. After that, for the last one also the same. Okay, that's why you have
less
two.
than or greater than this bit.
Okay, you have two.
So this
One is to get the first,
okay. So
and one is to get the last.
I
Okay,
think,
you want to get these two.
anything you want to ask?
Okay, so after finish calculate. So if you find that this first is less than large,
There's no question.
just like this. First is less. First is greater than large.
Yes. Beijing. Yes. Anything?
Swap. Okay. This one is not. This one is continue. So means until
On your mind if you want.
first greater than large. Okay. So when first greater than large, the loop will stop. The loop will stop.
Yes,
Then you swap.
okay. Both the merge sort
Okay.
and the quick sort, okay, has the same
Follow this algo.
space complexity, which is n log n. Okay. This is not written in the notes.
Okay. So that's why the most important thing is for quick sort is basically to find the split value. After you determine the split value, you need to find the first and the last. Okay. And finally,
Insertion sort,
you can split the list into two groups.
because you see they do not create any.
Okay. So the groups in the left hand side will be smaller or equal to the split value.
For example,
The right hand side will be all the numbers
no matter
greater than the split value.
how long is the array,
And the thing will continue
okay, how many
recursively. Okay,
the space
recursively.
just to when you swap these two things, you need to create one space. Okay.
Yeah, clear?
Swap 10 and 29.
So you try to understand it. Okay. So basically, I create everything for you.
29
Okay.
here,
So just try to understand the code. Okay.
back to here.
And then
Okay. One space is what required.
in the tutorial, let me see. Okay. This is sorting. Okay.
Only do have additional one space for keeping the one that you want to sort. Okay. So the complexity is very okay.
I put in tutorial.
But the consequence is time complexity.
Okay. Okay, the tutorial, you see, write a program character means integer change to character only. All this one already in. Very easy.
Anything else?
This also same thing. See,
Okay.
instead of character, you string only.
You're taking your attendance.
Nothing to
Also,
change.
all the best.
Change to string only.
For midterm test. By this
Number 3 is a bit different
okay.
because this one I need you to use linked list.
Okay.
Linked list.
So that you
Selection sort in linked list.
okay. Thank you.
This one also the same thing. Bubble sort in linked list. Bubble sort in linked list is quite difficult. Compared to array, bubble sort in linked list is very tough. Why? Because each time, if let's say you want to swap the value, you need to take out the link and then join back the link. Compared to array, you just swap the index. But if you are using linked list for bubble sort, you need to remove the next link, point to the new node, then the new node need to remove the link, point back to the original link. Very difficult. So that's why it's not the sorting algorithm. Some sort is not suitable for some data swap. Just like I mentioned just now, the insert sort is suitable for linked list. So this is bubble sort. I didn't put insert sort. I thought I have an insert sort here. 4 questions only. Yeah, never mind. Okay, wait. The lab is This one, special sorting, you see? Okay, I can change the condition. The odd number is always smaller than the even number. Okay? This one. This one is you need to have a product class. Okay? The sorting is by the price. So you need to modify a bit the sort test, so that the class support the product, by comparing the price. It's not compare integer character anymore. It's compare the object, the product object, based on the price. This one you can use the comparable. So same thing. Okay, this one I think is to check the performance. See, this one simple. You just change to 1,000 and then 100,000 random number. This one interesting. Basically you can see the performance. Okay, number 4. Number 4 is another algo. We call heap sort. This one is a bit challenging. I give you the algo, so see whether you can do or not. This is by heap. Still remember the binary search tree we did for the array. The one very tough one. This is using the heap sort for the binary search tree array. This is advanced level. This one interesting. So basically these are the questions in the sorting chapter. I don't think you can find all these questions in your previous senior. Okay. Someone asks, will we learn hash table this time? Yes. Next week. Next week we will learn searching. Okay, let me download this. Next week, no worry. So next week in the searching, we will learn the hash table. Usually you have the key and the value. We will learn in the searching chapter. Sorry. So any questions? Sorting. So these are the things in sorting. I'm not this few days cough. Not COVID, no worry. Any questions? So this week we will continue with the tutorial 8 and lab 7. Then please do your revision for this coming Friday. Anything you want to ask about the Miss Sam test? So if no, okay, when is the final? Final later after finish mid-sem first next week or later, I will inform you. Still have 1 month to go, no worry. So do your revision. So hopefully you can get a high score for the online test. It's very simple only. You look at the question also, so simple. So you continue. So I will see you again tomorrow in the lab, tutorial and lab. So we will stop here. So thank you for joining.